All right, we're moving into Chapter 5, and Section 5.1 is addition and subtraction of integers. So we've already looked at addition and subtraction for whole numbers, so now we're going to look at a bigger set of integers. Grade 6 is when students should start understanding positive and negative numbers and how they're used to describe quantities having opposite directions or values. They need to be able to use them to represent quantities in real-world contexts and explain what zero means in each situation. Okay, so when we represent integers, integers look like the whole numbers, and then we've also gotten their what we're going to call their opposites or their negatives. Okay. Your book uses the negatives up top, just to be clear that we're talking about the negative number and not subtracting. Okay, so they're going to put the negative sign up top there. The negative integers we're going to call the opposites of the positive integers. So negative 4 is the opposite of positive 4. 3 is the opposite of negative 3. So if I have 14, what's the opposite of 14? Well, that's negative 14. The opposite of negative 5 is going to be 5. And the opposite of 0 is just 0. Okay, so how are we going to model adding integers? So the first model we want to look at is the chip model or the charged field model. Okay. So when we're thinking about the chips, we're going to have different colored chips. We're going to use yellow for positive integers and red for negative integers. This should say each pair of yellow and red chips neutralize each other. So every time I get a yellow and a red together, that's a net of 0, right? A net charge of nothing. Okay, so if I wanted to represent a total of positive 1, well, I could just put one yellow chip or 1 plus, if I'm thinking about the charged field model, in my circle. That represents positive 1. This middle circle also represents positive 1. In this middle circle, I've got 2 negative chips or red chips and 3 positive yellow chips. I can pair together these 2 and these 2, and so they neutralize each other, and so I have a net of 1. So this represents 1. And in fact, this represents positive 3. I've got 3 yellows plus negative 2. Okay. This circle on the right also represents positive 1. Here I've got 4 positive charges and 3 negative charges. 3 pairs are going to neutralize, and I'm left with 1 positive charge. I can also model integer addition using the number line. So now our number lines not only have positive numbers, but they also are moving to the left with negative numbers. When you're using the number line, you always want to start at 0 and imagine that you're facing right. Our positive integers are represented by moving forward on the number line, and negative integers are represented by moving backwards on the number line. Okay? Now this is why those arrows, the arrowheads, are very important, because they're telling you direction. So if I wanted to find or model negative 3 plus negative 5 on the number line, I'm going to start at 0, and I'm imagining that I'm looking forward. So if I'm standing here, I'm looking to the right, but I've got a negative 3, so I'm going to move backwards 3 units. Okay, so that's negative 3. And then I'm going to add negative 5. Negative 5 also means move backwards 5 units. So I'm going to go to the left 5 units. And where I end is my answer. So the answer is negative 3 plus negative 5 equals negative 8. Let's do a couple more examples. Let's model -4 plus 5 using the chip model. So I'm going to start with my set. I have -4, so I'm going to put in 4 red chips. And I have +5, so I want to put in 5 yellow chips. I don't have yellow, so I'm going to use orange. 1, 2, 3, 4, 5. Now you can, to help yourself, remind yourself that these yellows are positive and these reds are negative. And then I'm just going to look to see what pairs up, right? So I've got 4 sets that neutralize, and I'm left with 1 positive chip. So -4 plus 5 is 1. So I have 4 pairs of yellow-red chips. Given at 0. And I'm left with 1 yellow or positive chip. So -4 plus 5 equals 1. This is the kind of explanation I want from you for this model. All right, what about the number line model? So let's model 1 plus -3. So I'm going to put 0 here and mark some numbers on my number line. Let's go to the left also, -1, -2, -3, -4. Okay, so I'm always going to start at 0 facing to the right. And I want to move forward 1 unit. So I'm going to move forward 1. And then I'm going to move backwards 3 units. So from here, I'm going to go backwards 1, 2, 3 units. That puts me at -2. So let's describe what we did. Move forward 1 unit. Then backwards 3 units. We end at -2. So 1 plus -3 equals -2. Again, I need this explanation. Okay, you need to describe what you're doing. I want more than just the picture. Let's look at another example. So this is, remember, those 6th graders need to be able to look at real-world examples. So here we have a thermometer. The temperature was -4 degrees Celsius. In an hour it rose 10 degrees Celsius. What is the new temperature? What is this doing? I need to add -4 plus 10. Moving up is going to be adding 10. And you can see I ended at 6. So the new temperature is 6 degrees Celsius. Once you've modeled the integer addition with your students, they should start to recognize a pattern. So we're going to start with some basic facts. If I start with 4 and add 0, I get 4. If I add 1, I get 5. If I add 2, I get 6. If I add 3, I get 7. Now, if I start adding negative numbers, so you can see there's a pattern here. If I start at the top, I have 7, 6, 5, 4. So if I'm going to add -1, it should be the next integer down. So 4 plus -1 is 3, 4 plus -2 is 2, and so on. So students should recognize this pattern and be able to use the pattern to help them figure out addition facts.